We're going to talk about Chapter 10's first section today. Chapter 10 is on finance, and Section 10.1 is on interest. All right, when you deposit money, the bank pays you a fee for the use of the money. All right, it doesn't just sit in the safe of the bank. They lend it out to people and make more money on that. So they'll lend out at 6% and pay you 3% interest. That was, classically what they did back in the day. Things are not quite like that now. But interest is the amount of money you get that the bank pays you in order to use your money. And the fee for using money is called interest. So interest is a fee paid for use of money. And then there's a few other technical terms. The amount that you deposit is called the principal. And sometimes it's also called the present value. And the amount after the interest is paid is called the future balance, or the future value. So those are the technical words used for these things. And we'll show an example of interest in a moment. Now, I'm sure you've probably had problems on interest before at some point in high school, right? Was there some sort of consumer ed class you took at some point? They don't have that anymore? Oh, well, okay. Yeah, I'm not sure what they do anymore. Okay. But, all right, well, if you haven't seen this, here we go. But my guess is you've seen things like this before. So let's take a look at the amount in a savings account. So we are going to look at the amount on different dates. And we're going to look at when money is deposited. We're going to look at the interest paid and the balance. So let's say on January 1st, someone deposits $100 into an account. At that point, the balance is $100. So here we have a principal. The principal is $100. Okay, so let's assume that the bank pays out its interest quarterly. So that means on April 1st, you will get some interest earned. And let's say that the interest earned is $1. Then your new balance is $101. Because on April 1st, you will earn that $1 of interest, and now instead of having $100 in the account, you have $101 in the account. 3 months pass, and now you get paid interest again, but instead of getting $1, this time you get $1.01. Why is that? Well, it looks like each quarter you're getting a 1% interest payment, and the first balance was $100, so 1% of 100 is 1, but 1% of 101 is not 1, but 1.01. So that's why you're getting a little more in interest this second period. And your new balance is $102.01. October 1st rolls around, and now we get another interest payment. This time it's going to be $1.02. Because it's 1% of $102. So now you have $103.03. And then the new year comes along, January 1st of the new year, we get an interest payment of $1.03, and our new total is $104.06. Okay, so there's an example of what we have. Now, why is the interest paid increasing? Okay, because they are paying you a fee to rent your money. You have more money, so the fee needs to increase. And this is called compounding. So why is the interest increasing? This is called compounding. Okay. So, in this example, we earn 1% each quarter would be the interest. That's the real interest that's being paid. Each quarter you're going to get 1% of your balance. But that's not how the bank is going to tell you what the rate is. The bank is going to say 4% interest paid quarterly, or 4% annual interest paid quarterly. Or instead of paid, they might say compounded quarterly. And the above situation in that table is what would happen for 4% annual interest compounded quarterly. That means each quarter you would earn a 1% interest. So this leads to a formula which is simple. Okay, if interest is compounded m times a year, and the annual rate is r, then the interest rate per period is I, we often use, and it's going to be r over m. So it's the annual rate reported divided by the number of periods that are used in the compounding. So in the previous example, we had 4% and we had 1% is equal to 4% divided by 4 times a year. That's what we had in that example. So an example of what we would do with this, if 3% annual is compounded monthly, what is the monthly rate? Well, 3 divided by 12, because that 3% is divided amongst the 12 months. 3 divided by 12 was exactly 1 quarter. So 1/4% per month, which turned into a number, a decimal, is 0.0025. Okay, so it's important to know how to transform the stated rate of interest into the actual rate of interest per compounding period, and it's just a simple division. Now what we're going to do is figure out some formulas that tell us how much is in an account after a certain period. We already did that above, right? We looked at these periods and we added but it would be nice if we had a way to do this without drawing a whole table. To just say, oh, what's going to happen at the end of 20 years? Instead of having to draw all the table, it would be good to have a formula for that. So that's what we're going to talk about next. The future value formula for compound interest. Okay, there's a bunch of variables in this. P is the principal, so that's the amount that is invested initially. I is the interest rate per period, and N is equal to the number of periods. Then there's a formula for giving you the future value. And here it is. F is equal to 1 plus I to the N times P. So that is the formula that tells you what your future value is. And that formula is exponential in N, exponential in time. And we know that exponential functions, though they may take a little while to grow, eventually start growing very, very quickly. This is why you start investing money when you are young, because it will have more time to grow. Okay, so now let's do a problem involving this future value. Let's suppose $100 is deposited for 10 years with interest paid quarterly. Find the future value if the annual rate is, say, 1%, 5%, or 10%. We're going to have three answers for this. We want to find what is going to be the amount in the account after 10 years under each of these interest rate scenario. So let's start with the 1%. Okay, interest is compounded quarterly, so I is going to be that 1% interest divided by 4. Right? 1% total over the year, but it's compounded quarterly, so we divide 1% by 4 to get 0.0025. All right, so now we're ready. We have all of the things we need, right? We have, let me label this. This is P. This is not quite N. N is equal to 4 times this, because there's 4 quarters in each year. And we have I now. So now the future value in the account after 10 years is going to be 1 plus 0.0025 raised to the 40th power times 100. So that's going to be the future value. Okay, so let's clear this. We want 1.0025, and then we need to make a bigger calculator so that I can see the things I need. Where's the good stuff? There we go. I need to raise that to the 40th power, and I need to multiply that by 100. Okay, so I have $110.50 at the end of 10 years. So you might think, oh, it's 1% per year. I have $100, 10 years, I should have $110. But that 50 cents is because of the compounding. That extra 50 cents that you have. Questions about that one? Are we ready to do 5% and 10%? Does this look right? This is okay? Okay, 5%. Now I is going to be 0.05 divided by 4. This is 0.0125. So the future value is going to be 1 plus 0.0125 raised to the 40th power times 100. Okay. Now I must make my calculator larger so I can get the good stuff. Okay, now we have $164.36. Now we think 5% a year, I should have an extra $50 at the end of the 10 years. But there's an additional $14 more because of the compounding. And there's a big difference between 1% interest and 5% interest, as we can see here. Especially relative to the initial investment. We've gotten over half of our initial investment back when we have 5% interest. And then, of course, the 10% problem. I is equal to 0.1 divided by 4. This is 0.025. So the future value will be 1.025 raised to the 40th power times 100. Okay, we get $268.51. All right, we should round to the nearest penny, of course. Okay. So we see we've almost tripled our money with 10% interest in 10 years. All right. So the interest rate is very important, very susceptible, especially when long periods of time are around. The interest rate can lead to very different outcomes. Okay, and then there's a present value formula, which is, it's almost insulting to write it down, but I'm going to write it down. The present value is equal to the future value divided by 1 plus I to the n. So let's say I know that in 10 years I want to purchase something that costs F dollars. How much do I need to put away today in order to have F dollars in 10 years? This is the formula you use for that. And it is the same as the future value formula, just the 1 plus I to the n is moved to the other side by dividing. It's the same formula. Okay, now we want to talk about one more concept for today. Well, actually, at least one more concept today. I want to talk about the effective rate of interest. Okay, now recall we just showed that 4% annual paid quarterly is not equal to really 4% annual paid at the end of the year. It's a little bit larger than that because you are compounding on the money earned in between the year. You're compounding on the money earned at the quarters. We showed, right, if we compound 1% quarterly, 4% quarterly, we get 1.01. And then we raise that to the 4 times to get a full year, and you get 1.0406. So 4% paid quarterly, or 4% annual paid quarterly, is equal to 4.06% paid annually. So it's actually a little bit higher than 4% paid annually. It's a little bit better than that. And this is called the effective rate. Interest. And there's a formula for the effective rate. And I'm going to reveal that shortly. If we have M compounds per year, and I is the rate per period, then the effective interest rate, which is called R with a little EFF, is 1 plus I to the M minus 1. And you'll see that's what we did in this as well, except I reported it as a percentage and not as a decimal. And so the effective rate of interest converts an amount of interest paid periodically into one of an annual rate paid once. An effective annual rate is what it means. So let's compare two rates that look pretty similar. Example, let's compare a nominal 3.65 paid quarterly with 3.6 paid monthly. We want to see which one is going to leave us with more at the end of a year. Okay, let's see. So the 3.65 quarterly, let's do this calculation first. First, we have to find the actual rate of interest. So I is 0.0365 divided by 4, because there's 4 quarters in a year. The number we get is 0.009125. So to find the effective rate of interest, we take 1.009125 and we raise it to the 4th power because there are 4 quarters in a year. The number we get out of that, and then of course we subtract 1, so we get 0.0370. So this is a 3.7% effective rate. So 3.65 compounded quarterly gives a 3.7% effective rate. Now, 3.6 compounded monthly, well, 3.6 is a lower nominal rate than 3.65, but perhaps the extra compounds might allow it to catch up to this 3.7 effective. So we have to see whether that's the case. So we do another calculation to figure whether this is true. So 3.6% monthly. I is now 0.036 divided by 12 because it's monthly, and that's 0.003. So the calculation we're doing is 0.003, 1.003 raised to the 12th power, and then we subtract 1 to get the effective rate. It's 0.0366, so it's 3.66% effective. So the better rate is actually the 3.65 quarterly. And it's very hard to know which one's going to be better unless you would do such a calculation. It's not apparent unless you do the calculation. Okay, let me write down the homework for Monday because we're basically out of time. This is section 10.1. 8, 10, 14, 20, 24, 30, 36, 40, 48, 56, 60, and 64.